Thank you for the intro, Sarah. I met Sarah for the first time a year ago, actually, in Amsterdam. We were at React.Amsterdam, and now we're both here talking about Vue, so that's pretty cool. And I'm going to be talking about full-stack Vue in the era of serverless computing. My name is Nader Dabit, and by trade, I'm a front-end developer, and I've been working with Amazon Web Services for about a little bit over a year. On Twitter, Medium, and GitHub, I'm Dabit3. I do a lot of talking about GraphQL and AWS services and implementing AWS services with front-end frameworks. I'm very active in the GraphQL community these days. I run a podcast called GraphQL Patterns and also a Medium publication called Open GraphQL. And we have around 50,000 readers a month on Open GraphQL. And we also just started a newsletter, and we're beginning to work with the GraphQL Foundation and moving over some of the GraphQL community resources into the foundation, which is kind of managed by community members. But when people think about AWS, they typically think about back-end development, DevOps, servers, serverless these days, et cetera. But I actually work on a team at AWS that specifically builds tools, SDKs, and services for front-end developers. And even though the team that I work with builds these types of services for front-end developers, the ideas and the philosophy that I'm going to be talking about today is actually not specific to AWS. So you can use some of the ideas that I'm talking about with other cloud providers or other third-party services. I think I'm going to be mentioning Cloudinary later on. Someone from Cloudinary was here earlier and gave a nice talk about accessibility. And there are really two core ideas to this talk. The first is the idea of reducing code and complexity by intentionally and strategically taking advantage of smart services and abstractions. The idea is this: code is a liability. When code is reduced or diminished, we're able to more easily and quickly jump in and out of our applications and build projects into our projects and be productive. Because there's less code, by nature, there's less bugs. The code itself is not a feature. Only the feature that our code produces is an asset. The more that we reduce the amount of code that we write, the lighter weight and more agile our software becomes. Our applications become easier to understand and less of an intellectual drag on our team. The second idea I'd like to drive home is this: developer velocity. When we're able to move quickly and just build things, morale on our team increases, our users are happier, and experimentation increases because we're able to try new things out and fail, and the failures aren't as expensive because there's less of a negative impact because we've invested less, both cognitively and physically. And to understand how all this is going to play out, let's first take a step back and look at how application infrastructure has evolved over the past 20 or so years. When companies and developers used to ship applications, we kept our servers locally. This means we're reliable not only for our application code, but also the hardware that ran our software. We were in charge of keeping our hardware safe and secure, and we had to deal with environmental hazards and network outages that were kind of out of our control. There wasn't much that we could do with CDNs and caching at this level either. So if someone from a long distance away was interacting with our application, chances are their HTTP requests were traveling a long distance to get there because we didn't have things like CDNs, caching, and edge computing that we were taking advantage of these days. Over the past couple of decades, though, we've started moving our applications to what we refer to as the cloud, but in reality, they're just a bunch of off-site and distributed data centers that manage our core infrastructure. We no longer have to deal with environmental hazards, hardware, or other things that that were once an issue for us. This was the first time we also started paying for compute power versus actual computer hardware. Scaling was easier, but we still had to manage scaling ourselves to some extent. And then lately, what we've seen come and start blowing up is this idea of serverless. And with the introduction of serverless, another layer of abstraction was introduced, and that did away with the need to maintain uptime, deal with server patching, and deal with server updating. These applications also scaled seamlessly without any work done by us, just based on our user base and the fluctuations in our user base. Serverless has exploded over the last few years, and it's continuing to gain momentum, really. But what comes after serverless? And that's kind of what the core of this idea of this talk is about. And as you're about to see, front end and back end are starting to move closer and closer together. Let's take a look at a paper that was just released 4 days ago, actually, by UC Berkeley that became pretty popular in the developer community, and I've seen a lot of references to this over the past few days. The title of the paper was this, Cloud Programming Simplified, a Berkeley View of Serverless Computing. The main idea or the main point of this paper was this, serverless computing will become the default computing paradigm of the cloud era, largely replacing serverful computing and therefore bringing closure to the client-server era. Notice the mention of serverful, and then now we're seeing serverless, but really the main point that I thought that was very interesting there was how they defined serverless. And the way that they define serverless is this. Functions as a service plus backends as a service. And basically what that means is stateless compute plus stateful, globally available, centralized services. So what are these stateful, globally available, centralized services, and how can we build applications utilizing this paradigm, I guess you'd say? Can I get a water, by the way? Sorry, mouth is getting kind of dry. So I'd like to talk about the idea of serviceful serverless. So these services assume responsibility for providing a defined set of services, and they're serverless in the sense that they inherit all the characteristics of a serverless application, i.e. they don't require any server operations, they scale, they don't require any need to manage uptime or anything like that. Thank you. But the most important characteristic about these is that they're essentially codeless. A few examples of these types of serviceful serverless services, it's a lot of S's, are things like Auth0 and Okta for identity management. There's Algolia for managed search. There's Contentful for content infrastructure, Firebase, AppSync, and Firestore for API services, database as a service, Cloudinary, and there's even machine learning and AI services these days, things like text track recognition. I think we have a dozen or so at AWS, but they're also available through other third parties. And when we used to talk about what a serverless application looked like, there isn't really a shared definition, but typically a serverless application was thought of as a bunch of serverless functions, Lambda functions, whatever, wherever you're deploying these serverless functions. And they were kind of interacting with each other. Maybe there was some event-based architecture going on there. But when you think of serverless, those two were kind of paired together, serverless functions and serverless. But in reality, I like this quote from Joe Emerson. The best serverless applications are this. They have three main characteristics. The first is thick client that handles all of the interaction logic between your APIs. Second is heavy and strategic use of managed third-party services. Services like I mentioned earlier, things like Cloudinary, AppSync, and Algolia. And then finally, you only utilize your serverless or glue functions when the heavy lifting can't already be done by a third-party service. So what are some of the benefits of building your application in this way? Well, first of all, we move further up the stack. We, as front-end developers, can start building out more and more sophisticated applications without having to kind of spend the time to learn all of these back-end resources. In the past, each of these back-end features took competent developers weeks, months to build. And because we're only working with a predefined set of API calls as front-end developers, and we're also working with serverless functions that are written in JavaScript, and since we're here at a JavaScript conference, we can probably write this code ourselves. We can use our existing skill set to kind of build out the entire back end by utilizing this infrastructure. We can hook into these services and implement these features with really no knowledge of how the actual back-end implementation was done, because all we're really doing is using their predefined feature set. And typically, this can happen at a fraction of the time and cost as if we had built it out ourselves. This is the ultimate enabler of developer velocity. This way of engineering enables us to iterate more quickly, and more cheaply, and it allows us to experiment more often and with less overhead than the traditional approaches of building these types of features would allow us to do by hand. most of these types of services are codeless. And because these services are created, managed by a third party, these services require us, for the most part, to write no back-end code at all, meaning our application itself has less code overall. And then there's the benefit of lower upfront cost. In this paradigm, we're trading basically capital expense for variable expense. Instead of paying an engineer X amount of dollars to build something or spending the time to do it ourselves, we're subscribing to this predefined feature set and not really worrying about the underlying implementation. We pay for the compute time that we consume, and there's really no charge until our actual code is running. And essentially, you don't have any costs until you have a large number of users that are like using your application, and then you have to start paying for your infrastructure. And then along with this less code comes less complexity. And this kind of moves the discussion from how do we decrease complexity to actually, and manage complexity, to how do we actually remove complexity entirely? Because this complexity simply doesn't really exist anymore. It's not in our code base, it's in someone else's code base, and it's someone else's responsibility. And then finally, and this is really important for us in general when you're building something that you actually want to ship, is these services are typically more secure and stable than rolling your own. That's because these teams that are building these things out are specialized teams that have been doing this for years and years. It's kind of their core competency. And you almost have like a specialized team of engineers building out your features for you. And it would be almost impractical, it would be impractical actually for you to do this yourself without investing just a really impractical number of hours. And then there's these things like unknown unknowns that you would run into building something out like that out yourself that you don't really know until you hit scale and you have a lot of experience there. So how do we kind of build these applications? Well, there are other ways to do it, but I'm going to talk about something that my team at AWS has been working on called the Amplify framework. So the Amplify framework is an entire framework for building out these types of applications. And we've really ramped it up over the last 6 months or so because we've seen a lot of adoption. And there are a couple of main pieces to this. The first is a CLI. The CLI allows you to scaffold, configure, and update cloud resources directly from your command line, from your front-end environment. And some people compare it to kind of like Ruby on Rails for cloud services. And then there's also a JavaScript library that you use to then connect to these services from your client application. And this is a list of some of the services that are supported by the framework. Authentication is a big one, but we're seeing really large adoption with AppSync and our serverless functions, which are a combination of either just deploying serverless functions or building out entire REST APIs. We've seen some GraphQL talk already. The cool thing about what we've seen so far is we're looking at how to actually interact with the GraphQL API. But what if our team, or what if us as a developer, we don't want to spend the time or know how to build out the entire back-end GraphQL API on the back end? You can actually spin up GraphQL APIs using this framework. And I'm going to try to demo that in just a moment. So we also have first-class support for different front-end client frameworks, and we started supporting Vue recently. So you can use pre-configured components that scaffold out entire pieces of functionality with just a couple of lines of code. So a couple of the things that you can do with these pre-configured components are chatbots, authentication flows, which we'll look at, photo pickers, photo albums, AR scenes, and VR, a bunch of other stuff as well. So let's take a look real quick at a demo. I would say, is that big enough? But, you know, or is that big enough? There we go. So I'm inside of a Vue application, and to initialize a new Amplify project, you just run amplify init, and after you run amplify init, you end up with this Amplify folder. And after you've initialized the project, you can start adding new features. So that's kind of where we are right here. So I want to add 2 features. I want to add authentication, and I want to add a GraphQL API. And I want to build an app to let people create a conference and let people like interact with the conference and see talks. Because after coming to this conference, I kind of want to like go home and start my own Vue conference. So that's what we're going to do. So I'm going to run amplify add API. Well, actually, let's add auth first. This is going to be for authentication. So this is going to give us two options. We can either walk through a configuration of our own and kind of choose our defaults, or we can take a pre-configured set of smart defaults. So I'm going to do that by choosing yes. And that's it. We've configured the authentication service locally. If we want to actually create it in our account, we run amplify push. But before we do that, let's add a GraphQL API. So to do that, I'll run amplify add API. Here, we're given the option of either GraphQL or REST. I'm going to choose GraphQL. We have the option to provide an API name. Vue.js sounds fine to me, but we can't do that, I guess. I'll just call it that. And then we can choose an authorization type. We can either choose API key or Amazon Cognito user pools. This is kind of, API key would be like an open API that anyone can connect to as long as they have the API key. And then Cognito user pool is an authentication provider similar to what we set up already. But we also support things like OIDC, so you can use Auth0 or bring your own authentication provider. And then they're asking us if we have an annotated schema. We don't. And we want to go ahead and create a schema. I'm going to choose yes and choose this pre-configured template that it's going to get us kind of started off on our API. So this gives us a basic to-do. I want to create a conference app, so I'm going to go ahead and scaffold out a base type of talk. This will give us a speaker name, a speaker bio, and the talk name. And this is kind of all we're going to need to get this going. So I'll go ahead and save this schema, and I'll continue. And then we've created that configuration locally. So now I'll run amplify push. And this is going to go ahead and create this in our account. So now it's asking us a question. Do we want to generate the code for our GraphQL API locally? And this is pretty cool because typically what you would do in the past is actually write out all your GraphQL queries, mutations, and subscriptions, the definitions for those, similar to how Sarah was kind of showing her definitions earlier. You would write those from scratch. We'll actually write those for you. You can choose TypeScript, Flow, or JavaScript. I'll choose JavaScript. I'll go through the rest of these questions. Nothing really too much going on there. And this is going to go ahead and create the resources in our account. After that's done, I'm going to actually jump into the next step here. In our project, we still have this amplify folder, and we can run amplify status. And this will give us an idea of what's going on in our project. So we have this auth and this API set up. So now let's actually look at how this code actually works. So I'm going to go into main.js and see how we configure our project to work with Amplify. We import Amplify and Amplify modules. We import this Amplify plugin, which is Vue specific. And then we import an AWS exports file that was generated by our CLI that describes all of the different services that we've enabled. And then we just call vue.use after we configure our Amplify project by calling amplify.configure. And then from there on, we can start using Amplify in our project. And you'll also notice here on the left-hand side, we have our GraphQL mutations, queries, and subscriptions that were automatically generated by the CLI. So if I open that up, you'll see that we have these queries that are automatically, they look at our schema, and they generate the operations that we would need to operate against our schema. And then in app.vue, we're going to look at how we can spin up this authentication flow, a GraphQL API, interact with it with just a few lines of code. The first thing we see here is this view if. We're checking if the user is not signed in. If they're not signed in, we're presenting this Amplify Authenticator component, which is basically an authentication flow. And let me go ahead and show how that looks. And this is the app running on localhost. So the first thing we want to do, since we're not signed in, is sign in. But first, I'll go ahead and create an account. And this is going to give me a confirmation code. Thankfully, my Wi-Fi seems to be working good. All right, so we've signed up. Now we'll sign in. All right, so we've signed in. We're actually seeing our name here because now that we've signed in, we have access to the user's identity. And I have this basic form that I've scaffolded out with a form that adds the talk name, the speaker name, and the speaker bio. So I'll create a talk called all right, okay, there we go. So I'll go ahead and create talk. So now our talk is created. If I go into my database, which I have open here, we'll see that we have this data is indeed in our database. And if I refresh, we're fetching the data and we're showing it in our app. So let's look at the code that made that happen. For one, we have a really basic form, and we have a for loop that's going over the talks in an item array, the items in a talks array. So we're not going to really worry about the UI too much because this is really just basic Vue stuff that you're probably already used to. But what we will look at is how do we interact with Amplify. The two things that we're going to look at for the most part are API and auth. Using API, we're creating a talk by calling a GraphQL API. You looked at how we could have done it earlier when Sarah gave a presentation with Apollo. You can actually use Apollo with Amplify if you'd like. You can use either the Amplify client for GraphQL, or you can use Apollo. So we call api.graphql. We pass in an object, which is our talk right here. And then we pass in the definition of the mutation that we created. And then the other thing we'll look at real quick is how do we actually fetch the data from our API. We do that here and before create. We do an async await where we call api.graphql, passing in the query. We get the talks, and we set those in the current state. And that's kind of it on that. I know I'm running a little over on time, so I'll go ahead and finish this up. But one thing to note is when you create this actual GraphQL API, you can go into your console and you can interact with it. You see the entire schema that was generated based on our base type. You can also do queries and things like that from the console. So we have like a graphical editor. So you can basically play around and test your API out. So that wraps it up. If you're looking to learn more about any of this stuff, the first place I would go would be the documentation, of course. But also I have this awesome AWS Amplify repo in my GitHub repo. I wrote an article that did pretty well called How to Build Serverless Vue Applications with AWS Amplify. That's on my Medium account. And then I have a blog post that's called Full Stack Computing, or Full Stack Development in the Era of Serverless Computing. That's on my blog that kind of talks about this philosophy in a little bit more depth. And if you want to follow me again, I'm Dabit3. Thank you.